All right. Welcome. Hello, my name is Scott Gannett, and I'm the Director of Marketing for Hirose Americas. I'd like to welcome everyone to today's webinar on smart warehouses and automation. So simply put, warehouse automation is the process of replacing repetitive tasks with automated processes and systems. But how do you optimize the robotic technology that automates those processes? Well, that's some of the insight we're going to provide to you today. Providing that insight is Jeremiah Stanek. Jeremiah is a technical marketing specialist for the industrial segment team with Hirose Americas. He joined Hirose in 2018 and is a graduate of Illinois Institute of Technology. He graduated with a bachelor's degree in chemical engineering. A few quick housekeeping notes before we begin. We will have a Q&A session at the end, so feel free at any time during the seminar to place your questions into the chat box, which is on the right side of your screen, and we'll answer those questions at the conclusion. If you'd like to see the presentation larger, you can simply click the three buttons that are on the center right side, and that will increase the presentation, or vice versa. So it'll increase the presentation, reduce the chat box, or it will increase the chat box and reduce the presentation. So with that, let me turn it over to Jeremiah to begin.
Thanks, Scott. Hi, everyone. My name is Jeremiah from Hirose Electric Industrial Group. So today I'll be going over a few of the different market trends that we're seeing in the smart warehouses and automation market. Let me switch to my presentation here. Awesome. So today we'll be going over a couple of different things. First off, I want to start off with sharing the market overview of what we're seeing out in the market and some of the trends and technology roadmap we have for our devices. Those devices include robotic arms, mobile robotics, so your AGVs, AMRs, drones, and then different types of sensors. The main portion of this presentation will be talking about the different challenges and some of the Hirose solutions that we can provide for these challenges. So let's jump in. So the warehouse automation market is big. It's actually expected to reach over $40 billion by 2027, which is only a handful of years away. But ultimately, what is causing this expansion? So the first point is COVID-19. So the pandemic has actually led warehouse operators to consider accelerating or quickening their timetables to adopt different types of robotics and automation in their warehouses, especially those who have successfully deployed these types of robotics have not only created safer workplaces, but also enhanced productivity to meeting the increasing demands of e-commerce. So e-commerce is actually our second point here. So since the start of the pandemic, since 2020, e-commerce has grown substantially. The rising number of warehouses directly correlates to that boom that happened in the last couple of years, especially with many retailers, big and small, offering different types of online shipping to homes or shipping from warehouses to the stores. This has increased the warehouse to a boom. It's actually projected that about 45% of all manufacturing will be performed by robotics sometime in the near future. So this leads us to a point of the number of warehouses. So if we look at this picture below here, since 2013 until about 2015-16, warehouses were increasing by a steady pace of like 200 to 400 warehouses. But especially if you look at 2019-2020, this pace has accelerated to 500 to 700 per year. I actually saw the new number for 2021, which is over 1,000 new warehouses. In 2022, we expect the same. So it's been increasing steadily just because of the last couple of years due to the COVID-19 and e-commerce growth. And the last market expansion reason is the advancements in technology. With all these warehouses having new vehicles like automated forklifts and pallet jacks, not only help the efficiency to a new level, but also helps draw larger attention to different companies, especially the larger ones with massive warehouses, how robotics can not only make them more efficient, but these robots are becoming better, more technology, smaller, lower cost, And especially with the shortage of labor in some certain areas of the country, this has helped further propel the market to grow. Now let's look at some of the types of devices we'll be talking about today. So there's two main categories. One is the different types of robotics. So we have robotic arms and AGV AMRs, so mobile robotics. I'll mention that many times throughout this webinar. So your AGVs are your automated guided vehicles, and your AMRs are your autonomous mobile robots. And the second type of category is your factory automation style of products, like your PLCs, different types of sensors, and your imaging cameras or machine vision cameras as well. So what kind of technology roadmap do we see in the last few years, and what kind of trends are we seeing in the next handful of years? So for example, for your mobile robotics, in the last couple of years, we've seen AGVs, so the guided vehicles that follow a set pattern in a warehouse. Those have been predominantly the main robotics over autonomous vehicles, just because they are easier to place in smaller warehouses, and it's an easier way to achieve ROI versus autonomous robots. But we're seeing a switch of trend, especially in the last year, and we're predicting in the next couple of years to the autonomous vehicles becoming more mainstream, just because as the technology advances and prices kind of go down for these autonomous vehicles, we're seeing an increased usage, especially if they're using many of these in a warehouse. They can talk to each other, communicate, and work around obstacles, humans, and really be all around better collaborative support over AGVs. So we're seeing that trend happening now. But not only for these mobile robotics in the industrial robot, the drone, and the sensors, we're seeing an increased need for different types of automotive components. So these components that are usually not only used for automotive, but usually these components are more higher robustness, better to in any types of shock and vibe environment. If there's any type of temperature needs, these components usually handle a lot better than your normal wear and tear products. So we're seeing an increased need for these type of components. Now let's get to the bulk of the presentation. So here we have a couple of different devices that I mentioned earlier and some of the potential challenges we see happening currently now or in the near future. So we'll start off with robotic arms. So one of the main challenges here is the narrow spaces. So robot arms come in a lot of different shapes and sizes. We have some resembling human form factor arms that are pretty narrow and small versus these larger industrial manufacturing arms that lift heavy pieces of equipment. So even though these two are very different, both face the similar problem of these narrow spaces in the arm itself. Just because in these robotic arms, there's a lot of different axis points and motors, DC, stepper, servo motors going through it. And within these arms, there are tons of different wires. So your wire to board, wire to wire, or just different wires on different components in general. So this causes us to have a lot of different wires going through. A lot of times these very slim and narrow spaces. So having a slim inline connector is really such a good connector or component just in general to use to fit and squeeze as many wires as possible. This leads us to a similar challenge in the robot controller itself. So within the robot controller, we do have many different types of boards within the robot controller, like the amplifier board, you have a power supply board, encoder board, just a main sub board. So there's a lot of going on inside these robot controllers, which usually are trying to become smaller and smaller as technology advances. So as you can see here, we have a lot of different types of components. We have connectors that handle higher current. So these are usually a little bit larger. We have some of them are right angle, some of these are vertical, or even inline connections going through and connecting all of these boards. Even at the I/O connections, we have some robust I/Os here on the left, and even down here, we have a lot of D subs, RJ45s, or even next-gen Ethernet connector solutions like our IX Industrial labeled here, and not to mention all the board-to-board. So as you can see, a lot is going through this robot controller itself. So having different variations like straight, right angle, or inline connections help give it extra design flexibility to the engineers and see which components can be placed with as small as possible size. And then finally, the last challenge they face is having a strong, robust industrial I/O connector. So with almost all robotic arms at the back base of the robot, will this be a similar connector to this, connecting the controller to the robot arm itself. In certain situations where the controller is in a different room than a robot arm, usually we'll also see a panel connection happening. So there's either a direct or an inline connection is needed. So what are some of the instances or features needed for this type of I/O connection? So there are three main ones. For one, since it's used in a lot of different environments, it needs a robust design. So usually we see a zinc die-cast shell type of connector being used just because it has added toughness, robustness, and a quality and a strong performance. So usually this can go up to about 600 volts of capability. So depending on the robot arm and size, this could vary a little bit. But one of the main features is user-friendly. Just because there may be a lot of different operators working on this robot itself, having a very intuitive locking feature and one that once it's mated, there's no mismade prevention, there's no accidental removal, just because that could be really dangerous, especially if these larger robotic arms working on heavy machinery or lifting heavy pieces of equipment. So a very strong and intact lock is needed. And on this next slide, I want to show an example of two different types of environments that these robot arms could be in. So for example, on the left here, we have a clean room type of application where this robot arm is in a clean room. So usually here, there's not much of precipitation or any types of water. So usually no water resistant type of connector is needed. And also for this type of room, there's not a lot of shock and vibe. So just a simple double-sided latch, positive latch, or button on each side of the connector is suffice, just because there's not a lot of shock and vibe. Whereas on the other side, for the harsh environments, say a manufacturing or food assembly line, there might be a lot of dust, moisture in the air, so you need maybe a slight splash-proof type of connector, maybe IP65, but most importantly, there will be a lot more shock and vibe. So a more industrial latch that you have to probably maybe close with both hands, and once it's closed, there is no chance of accidental removers needed. So depending on the specific application where the robot arm is used, there's a lot of different varieties, which is a common theme in this presentation. So those are the three main challenges of robotic arms, and now let's move on to more of the mobile robotics, AGV, AMR types. So the first challenge we see is another times the space-saving design. So as this technology advances, we see some kind of dual sort of products where you have the AGV or autonomous vehicle on the bottom here connecting a robot arm itself. So a two-in-one product for collaboration. So we do face those narrow space challenges in a robot arm, but we also face similar challenges in the AGV or AMR application. Just because there are so many different components that go inside these mobile robots. Here's a kind of a good example of all the different components that can go inside these mobile robots. If we just look at the top here, there are a lot of different camera, LiDAR, radar, and different sensors, just so these mobile robots can understand what's in their surroundings to maneuver out of these obstacles. So there's a lot of connection points there. But we also have bigger connection points, like the battery connections using high-powered connectors, or even the motor connection, where you usually have a motor power connection and a motor signal connection. So very similar theme. There are a lot of different wires and boards inside this mobile robot, which as technology advances, these things are getting smaller and smaller, so you can use more and more numbers of these mobile robots in the warehouse. So with all of these different components and space restrictions, what are some of those possible solutions that we have? So one of the solutions, since there are a lot of components, these do have to be powered somehow. So since usually these power connectors are larger, bulkier, and take up more space just because of the voltage and current needed between these pins and contacts, Hirose has actually developed some of our connectors that have a smooth contour, which we like to call it, where the edges are a little bit rounded. So even though it's an inline or a wire-to-board connector, it's more shaped like a circular connector. So it can fit through these narrow spaces. You can pass by different wires just so it's easier to connect, while still maintaining a very high current. We have some options from 5 to 10 amps, or even to go up to 60 plus amps for an inline connection. So there's a lot of variety there to be able to handle power supply, but yet still maintain a very small size form factor. The next issue we see is a new one that we haven't talked about yet, is signal integrity. So AMRs are required to recognize their surroundings more and more accurately, especially when they're working around humans. So for this reason, there's a ton of different sensors, LiDAR connections, and the resolution of each of these are becoming higher and higher, which requires a higher transmission speed. So basically, this transmission speed is achieved by using high frequency electromagnetic waves, and this emits a lot of different types of noise. So this noise not only interferes with other sensors, but it also diminishes that signal quality. So it could result in different types of errors. And if there are errors or failures in the sensors, this could result in any types of malfunctions. These robots can bump into the other robots, or maybe different things around the warehouse. But the worst case scenario, interrupt human workings. So there could be cause of damage or injury, which is the worst case scenario. So how do we stop all these different noises from these connectors? One of the solutions is to use noise resistant or EMI free connectors. So from these noise resistant connectors, it allows for good signal transmission from all these different cameras, radars, and LiDARs. And Hirose products have different path signals and noise to reduce and eliminate any type of noise inside and outside of the cable before the signals reaches the receiving device, and preventing any type of malfunction. And finally, the last issue is a lot of these mobile robots do operate in different types of environments with high shock and vibration. So this is the last issue that I like to discuss for mobile robots. So a lot of times these robots are having heavy loads placed directly onto the device, or even vibration from the floors and the motors is causing board amplitude within the PCBs, even if the PCBs are fixed with a spacer. So this board amplitude causes not only contact deterioration, but eventually contact failure, just because of the male and female contacts sliding against each other continuously. So with all this board amplitude, or the rougher environments that they place, what sort of solution that could we have to ease this type of contact damage? So one of the solutions here is process floating connectors. So we have developed this type of technology to allow a little bit of movement within the connector, especially when it's mating. So when you're using multiple PCBs, multiple of these board-to-board connectors on a single PCB, there is a lot of tolerance stack up, which may increase the chance of contact damage. So we have these 4 of these connectors being mated by a robot here. As you can see, each of these with a floating feature can help offset any type of tolerance stack up, which is really useful in a lot of different types of environments. But one of the specific series, our FX26, actually has floating in a Z direction, so it can absorb some of that board amplitude. So this is really effective to not only decrease board amplitude, but also assure and to have a reliable and sustainable operation, even through a lot of shock and vibe environments, bumping into things, or maybe robots being moved or continuously with different objects. And now let's talk a little bit about drones, which are a lot different than the other 2 previous applications, where not only does it fly, but it's very weight and size sensitive. So the drones in general have grown exponentially in the last 10 years. We see many used for different uses for video recording, imaging, and other uses, but it's also in warehouse to do different types of inventory auditing, cycle counting, stock finding, etc. And usually this is done by having some sort of scanner, camera, reading different barcodes or QR codes. And depending on the specific use, each drone will be slightly different in terms of the components it's needing. So some of these I/O components will be internal, or some of these will be interface connectors, where if it's transmitting video, you need something that is shielded, or if it's used maybe in an indoor versus outdoor environment, there's different solutions having waterproof or non-waterproof capabilities. But the main features needed is the small size, which is our next issue. So similar challenge to versus the mobile robotics, there are a lot of different components that go inside this drone. So as you can see in this image here, there are components like each taking up space and each of these adding size. And the biggest issue with adding this different size and weight is that the battery of this drone decreases dramatically as the more weight is put on. So usually these drones are holding some sort of camera, or it could be maybe a delivery drone holding packages that's already adding on additional weight. So having any type of very light or space-saving connectors is highly a must-need. So that's why Hirose has some great micro board-to-board connectors that is, if you look in the image to the right, are a fraction of the size of a penny, which are not only very small in size, but they're also very light in weight. And usually when you have this type of small and lightweight connectors, they might not handle the best types of current or voltage capacities, but actually this micro board-to-board connector here can handle between 3 to 5 amps of current per pin versus 2 to 4 different pins that it has. So not only is it small size and weight, but it also can pack a decent amount of punch and current to power different components of a drone. And switching to wire-to-board connectors, there's always demand for smaller and thinner products. So usually the conventional product is a 2mm pitched wire-to-board, which not only adds quite a bit of size as you expand the pin count, but also quite a bit of height. So there are a lot of different low-profile solutions that go down to about 1mm in stack height to fit this low-profile and low-size type of connector to need. And an interesting feature about this connector is it is mated by a vertical mate through the top. So the connector does not have to be at the edge of the PCB board. So you can put them more in the center of the PCB board and have different components at the edge to allow for added flexibility in the PCB board design. And lastly, Hirose does offer many different types of connectors that are plastic and circular to add on this additional waterproof or lightweight type of connections. So there's a lot of different components that you can mix and match with depending on the specific design that is needed. And the last challenge for drones are the data connectivity and connection issues. Similarly to the mobile robotics, drones are not only commonly used for inventory checking, RFID, etc., but also for surveillance, transportation, moving inventory. So there is a high demand to use higher resolution imaging, videos, especially in 4K or very soon to be 8K resolution and video support. So that leads us to using a higher gigabit per second data rate. So having connectors to be able to not only meet the space needs, but also offer lightweight solutions to keep the battery life, signal integrity, and weight in optimal levels. So this is where Hirose offers great solutions for your micro-coaxial connectors that are not only very light in weight, but they have the higher data rate transmission speed and also are shielded to combat any EMI. And now, finally, to our last application that I want to talk about, the last type of device are sensors. So sensors require unique features. So in the last couple of years, usually for these devices like the robotic arm, the mobile robots and sensors, they operate independently to an operator, feeding different types of data back to them. But now, as we see last year, even in a couple of years in the future now, all of these are interconnected and automated to optimize devices. If it's either connected to the cloud or a 5G network, they all are sharing data. And with this, all of these devices have to be connected to some sort of interface connector to transfer that data. So usually there are a lot of different types of components and needs. Some of them are waterproof and need to be compact for your analog or digital sensors. Or if they're used in a heavy moisture or dust environment, there are different panel-mounted connectors for extra shock and vibe prevention, or even your non-waterproof options. We have connectors like the HR10, which is the de facto standard for a lot of different cameras, and even high pin and high density type of I/O connectors. So that theme of having a lot of variety comes back again. And one of the biggest challenges that we see is, especially for these sensors, a lot of times they may be long and it might be hard to assemble. So usually we see these three trends in the industrial sensors. One, a recurring theme as well, small size. Two, shielding, but probably the biggest one I always hear back from feedback is the cost it takes and the assembly time of these connectors. So that's why Hirose actually started with one of their main features, the one-action lock. So usually for your FPC flex connectors, you have to lift up. So the connector comes in a closed latch position. You have to lift up the actuator, insert the flex cable, and then close the actuator, three-step process. But with this one-action FH series that Hirose has developed, you can get the connector, the actuator be in a closed position as shown on the left here, and you can just slide in the flex cable and it's fully mated right there. And then a simple one-step process instead of a three-step process, which not only saves time, but a lot of times these flex connectors have a 0.2 or 0.25 millimeter pitch, which is super tiny. And if the operator is not, or the manufacturer is not careful, if you lift the actuators a little bit too hard, they may break off, especially on these smaller flex connectors. So having this one action lock where you don't have to touch the actuator at all to insert the cable really helps with decreasing any types of failures. And I want to show a quick video here, just showing some of the robotic assembly that's allowed for these one action series to help quicken and make the manufacturing process a lot more efficient. So you can see here, these robotic arms lift the actuator to remove the cable and remove them themselves. They can also mate the cable directly just because it's a simple one-step process. And finally, our last challenge, smart connectors and the wave of Industry 4.0. So Industry 4.0 has been around for a little while now, but here are some of the recent trends that we've been seeing in the last couple of years. One is that industrial Ethernet continues to take market share. It's about 2/3 of the market right now for newly installed nodes in factory automation, where Ethernet, IP, and Profinet are the leaders. In recent years, field bus is slowly taking decline. But we've seen it's mostly halted. For one reason, it could be due to the pandemic. Factories are most likely to stick to their existing technologies just because there were uncertain times in the last 2 to 3 years. The last trend we see is wireless, where wireless is growing very quickly, or in the past we just see a 24% growth. But we're still waiting to see the full impact of 5G factories. But overall, the theme is industrial Ethernet is the biggest portion right now in different types of factories. So what kind of solutions are there for industrial Ethernet for Hirose? So Hirose actually has developed a next generation Ethernet connector, which is the IX Industrial. So this connector is actually, the main feature is the small size. So compared to your typical RJ45, it's about 75% smaller in size. But not only the size aspect of it, I know in my personal and professional life, and many of yours probably too, we've had an RJ45 connector that has the little plastic latch be broken off, and then you're stuck with a connector without a latch. So the IX Industrial actually solves this issue where we have the positive latch, a double-sided positive latch molded into the housing. So it's much more robust and much more shock and vibe resistant versus other solutions out there. So it's a really good connector for industrial Ethernet and just industrial applications. But thank you for taking the time in this presentation. Now we'll be moving on to the Q&A portion. So if you do have any questions, feel free to put it in the chat on the side there, and we can help answer those questions.
All right. Thank you, Jeremiah. That was really good. I did have a couple questions that are in the chat, so I will start with those. Let me kind of start where we finished. You showed some IX industrial versus RJ45. Is Hirose supporting the cables with the connectors?
So Hirose does not support those cables, but we do have recommendations for which cables work best and which suppliers can help assemble those cables for you. We also have different partners that supply the completed cable assembly off the shelf if you'd like to order just quick and easy completed assemblies and harnesses.
Thank you for that. Okay, I've got another one here. During the drone section, there was a tiny micro board-to-board connector. Just can you give us an idea on the rough size of that connector?
Yeah, sure. Yeah, that I know the image you're talking about. It's a really cool image of the little micro board-to-board. That's actually the smallest pin count of that version. That's probably shown in the image there is about 2.5 by 1.5 millimeters in length and width. And the height's just over 0.5 millimeter in height, so it's very tiny. And even if that tiny connector, that they do have designated power and signal pins there, which I mentioned during they can handle about 5 amps of current on those power pins.
We got one more question here. This one was kind of going back to the beginning, Jeremiah. For the robot arm, they said they believed you showed what was a DF62 connector. Mentioned it is commonly used for robot arms. Could you give us an idea of what's the lowest wire gauge for this connector?
Yeah, the lowest wire gauge is about 30 AWG, and it can go up to about 22. And usually for those robot arms, there are also different robot cables we see being used where these are even thinner cord wires. But the lowest wire gauge is 30.
Those were the questions that were in the chat during the session. Does anyone else have any additional questions they'd like to direct to Jeremiah or any one of the Hirose team? Give it going once, going twice. Okay, it looks like that's all the questions we had from the session. So we just would like to really thank everyone for joining the session. Please don't forget to visit hirose.com if you have any additional questions. Actually, I have another question here. What sector of the industry do you see moving quickest today, Jeremiah?
Sure, yeah. For the industry, I mean, that's pretty broad, but we do see robotics growing exponentially very quickly. Usually those are not only for warehouses, we see a lot of times that's for consumers or even different types of medical facilities as well for rehabbing and hospitals, or even just different types of cleaning robots for these industrial sized buildings, and not only just for homes. So robotics is one that is expanding very quickly, and we're seeing a lot of different trends coming in quick. So that's why I think some of the challenges we relayed here today would be really effective for especially the next upcoming years.
Great, thank you. If you have any additional questions, or if you're interested in one of our sample kits that we will give away to participants of this webinar, please email Jeremiah. And you can see his email contact information right here. And we will be glad to provide this Hirose webinar sample kit as a thank you for joining us here today. All right. Okay. Unless we have any last minute questions, I believe that will wrap it up. I would like to once again just thank Jeremiah for all the information today and the time. And we look forward to servicing you with all your connector needs here at Hirose. I hope you have a great day. Thank you, everyone.